Alright, so it's 8:05. Let's begin session number 3. I'm turning on my camera, by the way, for those who are curious. So, hello and welcome to session number 3 of what I'm calling Make It Move. This is where we learn how to make things move, it being the robots in FRC. Today we're going to be learning about controls and commands. So, if you guys recall, for the few of you who were in our first session, I went over the code, what it looks like, and how it's structured. And I did leave off one type of file, commands. I went over subsystems, I went over the robot container, I went over all of this, but not commands. Well, today we're going to look at commands, and along with that, we're going to talk about more in depth about controls, how these controls connect with the commands, and how all of this ties together. And for those of y'all who weren't here on session 1, I will give you guys a review, like a sort of rundown of what went on. So, today we're going to talk about some structure. We're going to make it brief. We're going to talk about controls, what the controls are, what we use this year, the anatomy of a subsystem, again, and the anatomy of a command. And by anatomy, I mean just how it's structured, what it looks like, and what each aspect of the program does. And I'll assume that you guys know what basic Java is, like just what the code looks like in general, what the dot means, what parentheses means, why you need a semicolon after each line, how brackets work, that type of stuff. So, let's start out with a quick structure of the .java files. So again, for those of you who are in session 1, all of this will be review. But if I go ahead, for those of you who are new, I have posted the link to, whoopsies, wrong link, hold on. That's a specific file. I've posted the link to our GitHub that we used for this year. This is the code we used for our robot. So that's this file right here. So once you open it up, you're going to see onto the left side something like this. If you expand all the windows out, you will see this right here. Note under commands there is an extra file, autopivot PID. That was because that was a something that we added on day 2 of competition that didn't appear on the GitHub until today. So if you notice on the left side, there's a bunch of files, a bunch of .java files. For those of you who are like taking a really basic CS course, you guys might only be familiar with one file at a time, like one chunk of code, not multiple file directories. You might be familiar with that type of stuff. Again, I am not enrolled in CS at Bel Air. I haven't been since sophomore year, so I'm not sure what exactly the curriculum is like there, or at other schools in general. But I want you guys to remember that Java is object-oriented programming. What that means is that each .java file is a class, and we work off of these classes. We have imagine a bunch of objects, like for example, a calculator, a Xbox controller, a pack of, I don't know, like a roll of tape. All of these can be thought of as objects, and they all have attributes. Like for example, the color of this is green. It's around 4 inches long, 3 inches tall, that type of stuff. Those are attributes, and it has functions. For example, class can be like, it could have a method like, I don't know, like imaginary, rip a piece of tape off. Like that. So, remember that Java is object-oriented programming. Every single one of these .java files is technically a class with attributes, and we can call these attributes anywhere within from the code. So, if you go in here, go to the folder src main, and then I think I already linked it there. Go to Java FRC robot. Navigate to that folder, and you will see all of these files. So if you open up subsystems and commands, you'll see that. Once again, robot.java and main.java. You don't touch those at all. Those are for internal functions. If you touch something, you might not be able to fix it. So I just wouldn't touch it. Robotcontainer.java is where all of the magic happens. This is this is where like you put your file imports, you initialize all your subsystems. This is the whole thing, like in a nutshell, kind of. If you think of the code as a nut, robot containers, the nutshell. Constants.java stores constants, obviously. What that means is you have like the various attributes of the robot, for example, like the IDs for the Spark Maxes, or like kinematic stuff, what ports they're connected to, what ports the various motors are connected to, and so on. And by the way, for those y'all who have just joined, can you please change your Discord username to your real name so I could identify and call on y'all? That'll make things a lot easier. If not, then I have no idea who you guys are. Now, obviously, like if you have the Beloit role and you go to Beloit High School, I probably know who you are. But for those of y'all who are not from Beloit High School, may you please change your nickname to your real name. Just a reminder, thank you. So that's constants.java. So today we're only going to be looking at robotcontainer.java out of these. And we're going to be looking at the subsystems and commands underneath for today's session. So we're not going to be looking at constants.java either. That was just a quick review. So subsystems are the various subsystems of the robot. For example, amptrap.java. This is the code we used for those of y'all who are participating in the season, that yellow, like orange elevator that Sir Gary brought over. That's what amptrap is. The shooter. This is the code for the shooter. The green compliant wheels with the Krakens. So these are all subsystems, and that just contains code for like the various subsystems of the robot, like what the ports are connected to, or what the various basic functions are. And if you want more info on that, go check out session number 1. Next up, we have this last bit called commands. Now, commands are a little bit weird because technically speaking, a command is a thing, right? But it's not like a tangible thing. Like, for example, a subsystem, it's a thing, right? A subsystem, if you boil it down to its electronics, are one or more motors, maybe some pneumatics, maybe like a sensor or something like that. A subsystem is a physical object, but a command is not. So that's what makes commands a little bit weird, and it's a little bit hard to work with, but that's what today's session is for. So commands are, well, first of all, commands. They are lines of code that tell the robot to do stuff. And every single command, I want y'all to remember this, every single command is connected to one or more subsystems. It could be multiple, it could be just one, but it's at least one subsystem because a command is for a subsystem. It acts onto a subsystem. For instance, pivot PID, well, I'll actually look at this one for example. Pivot PID, well, notice how I say there's a pivot subsystem, right? That's this thing right here, the pivot subsystem. So if you remember our robot from this year, we had on the shooter like a wrist sort of, and the motor right here that rotated the wrist. I want to give the people who are watching this a visual example of that. So the pivot, like we had a shooter that was like a wrist, it would fling the node up. The pivot. Whoa. So the pivot was like this arm thing, the wrist. It spun the wrist like that, such that we could shoot from different angles, essentially. So that's the pivot. The pivot PID is, it's a PID command, but like you don't have to know what that is right now exactly, but I'll show y'all later. The pivot PID command is the command for the pivot. It's an set of instructions for the pivot to move in a certain way. So that's a command. A command, when executed, when you create a command, you run the command, it does something to a subsystem. If you code it correctly, though. If you don't code it correctly, maybe not. All right. Buttons and controls. Let's get to the good stuff. So this is the diagram of a controller. I'm going to show you guys the one we used this year. This, and I'll give a visual example. Where is the photo booth? I have a question, it looks like. Yes, Kat. What does PID stand for? Oh boy, I do not want to open this can of worms. PID, it's a way of I will teach this more in depth. This is a session 5 idea plan for me, but PID stands for proportional integral derivative. For those of you who have taken calculus, you might know what those terms are, integral derivative, for example. But it's just a way to make movement more accurate. So, for example, if I want to move an elevator to a certain height, I use a PID to sort of get the elevator to its precise location. It's by varying the speed of the motor. And I'll get to the reason why in about 2 weeks' time. But that's what PID stands for. You could Google more on if you want about the topic. Yeah, it's tuning, basically. That's exactly right, Kat. So, yes. Yeah. And there's also a ton of resources online about PID if you want to get a jump start on that, if you're the model students, should I say. But yes, very good questions. And once again, if you guys are confused about anything, feel free to DM me, private message me on Discord with any of your questions, if you don't want to publicize them, of course. Back to controls. So this is an Xbox One controller. This is what we used for, and let me give a visual example. This is the controller we used. We actually had 2 of these, one for driving and one for subsystems. So we use this thing, and I want to go over the buttons for you guys, what we called them. So these 2 were the joysticks. These on the drive controller, they controlled the drivetrain. So this was movement, this was rotation. And these joysticks, what's neat about them is they actually have buttons. Like if you could push down, I know it's kind of hard to see, but you could kind of push down on these, and that'll also be registered in the WPI lib signal. Same goes for this one. We have the D-pad. So this is like the up, down, left, right thing. We have, of course, the iconic, I don't know what you call group of 4s. I know it's a trio for 3, but the iconic group of 4 buttons, X, Y, A, and B. We use those for various controls as well. And this controller is 3-dimensional, meaning there's another dimension to it. This is what housed the 2 bumpers. So these are like buttons right here. And then these are the triggers. And since there's 2 of them on each side, there's 4 of them total. We call them the left bumper, the left trigger, and the right bumper and the right trigger. So that's that. Those are the controllers for Xbox One. That's why I had to bring this out. So glad we got stuff out of the class before the end of the school year. So where do we connect the controls? This is like one of the main curiosities I had when I started programming. It was like, okay, yeah, so we use the button, the controls, and the robot moves. How do we connect them? How do we establish that connection in the code? Well, it's pretty simple. Go to the robot container, and then go to lines, it says 97 and 103 to 109. So, I guess it's 98 now. My bad. Line 98. You see a line called configure button bindings. So if you know basic Java, you know that line number 98 will simply run the function or the method that's titled private void configure button bindings, and that has like 50 lines of code underneath it. So that's that. And then if you look at lines 104 to 110, 103 to 109, the line shifted by 1. I recommitted it to GitHub, so I think GitHub, not GitHub, I'm sorry. I recommitted it, so the lines got shifted by 1. So if you look under there, this is how we connect the controls to the drivetrain. So what this does is it sets what's called a default command. What that means is the default command is like, okay, every single time we run the code, we're going to periodically check what's the state of this joystick. Like, we're going to look at the axes, because if you're wondering, the way they read the signal of a joystick is they take its X position, so it's left to right, and they take its up down position. So they actually split it into an X component and a Y component. So if you think of the joystick, it can move along a 2-dimensional plane, kind of. There's an X-axis, a Y-axis. That's what's going on here. And then on the other joystick, that's rotation. You only need 1 axis. So you need 3 axes of motion. So you need forwards and backwards, left right? And then finally, because it's a swerve drive, rotation. So you need those things for a proper swerve drive, and that's what these do. So usually the swerve drive stuff, it comes with the template. There's code templates everywhere. So you don't need to worry about that. I just want you guys to know where you could find it in case, like, for example, you want to limit the speed that the swerve goes at. 14 meters per second is a lot to handle, guys. So that's why, yeah, I went and did this. So I just want you guys to understand what is going on here, rather than dissect every little bit of the code, because you're not going to be coding any of this. It's already going to be preloaded with the template. This is the rev template. This was here already. So don't worry about this. What I want you to worry about is configure button bindings. This very lovely function right here. It has, and I kid you not, every single button function that we have used. Whatever we didn't make the final cut has been commented out. By the way, helpful hint. I will this is obviously going to be a given, but if you want to comment something out, use 2 forward slashes. That's going to make the line still visible, but it's not going to run the code. So if you want, for example, to explain something, then that's what that's for. Where is speed? Yeah, so what I actually did was, what essentially this does, and I have to get into this now, but what it essentially does is that if, for example, I have the controller fully upward, that's going to drive the robot full speed ahead, because it's going to read a signal of 1, which is full speed, and it's going to apply that much power to the robot. So what I did for speed, to control the speed, was I had a drive limiter constant, and I set this, it's under constants.java. I had that there, and then I set it to be a number between 0 and 1. So for example, 0.5. What 0.5 did was it reduced the power by half. So the swerve will only go at half speed, and that was just because we were getting to grips with the swerve drive. Eventually we were able to run it back and put it remove the limiter so that you could go at full power, and gradually increase it. So that's speed. Lines 106 to 107 are not the same. Yeah, notice this one character right here. Y, and that's Y, and then this is X. So there's one character difference there. Yeah. Hope that answers your question. Guys, Cat is beating you guys on questions. My God. Be more like Cat, guys. Ask some questions. Anyways, that's fair. Okay. Yes. Yeah, 106 and 107 have X and Y, and then so left Y regards it's this joystick right here, the left joystick. I don't know if it's right to y'all, but it's one side of the controller. Line 108 has the right joystick, so that's get right X. That's because that's the right joystick. All right. Hopefully that answers your question. Again, be more like Cat Huang in terms of asking questions. Finally. Yes. Okay. Yeah. Kalyani just said, I suppose you would call the group of 4 buttons a quartet. I forgot that word existed. I'm sorry. Yes. What do you need help with? Okay. While they type the messages out, I will move on. Okay, Pranay, yes. What is apply deadband? Okay, so a deadband, again, for the sake of time, I'm gonna briefly explain what a deadband is. So a deadband, basically, it's normal, it's customary to rest your hands on the controls when you drive, or the joysticks, right? But the problem with that is, if you jerk it just a little bit, the swerve drive's gonna move, right? And it might move out of position or whatnot, and you don't want that to happen. So a deadband is basically a room of a margin for error. So that, for example, if you move the controls 0.1, 1%, it's not gonna move because that can happen because of jerking and stuff. You rest your hands on it, you shift your thumb a little bit forward. So the deadband is just to prevent that from happening. Yeah, it's like a dead zone, dead zone. And you can adjust the deadband So like you could have like a 0.1 deadband and only move if your joystick is past 10% speed or 10% inputs. But yes, we got to move on. Configure button bindings. Again, keep asking questions. But just note that if you ask anything that's like miscellaneous kind of, I won't spend too much time delving on it because that'll be talked about later, most likely. So, configure button bindings. These are all of the buttons we used in the robot. So let me just go ahead and go over a line. So let's just take a look at each one of these lines and see what's going on. So look at line 169. Though I think it looks like it's now line 172. So go to line 172, not 169. You will see a comment that says shooter, and that's it. So look at this line. m.subcontroller.leftstick.onTrue new run command mshooter.speaker scoring mshooter. What does that mean? That's a good question. In fact, all the questions y'all have been asking are good questions. Keep them up. It's just that we do not have a lot of time here. So I'm going to color code it to make it easier. So I did go over this a bit once in session number 1. But basically, every single dot or parentheses separates one attribute or aspect of the line from another. So the red M subcontroller, that's actually the white controller we use, not this. This is the driver controller, but the first arguments, essentially, the first set of lines is, the first word is the controller involved. So M_subcontroller, that refers to the subsystem's controller. In orange is the button involved. So the left stick is, again, as I said, you could press these joysticks down. That's the left stick. It's a button input. I'm not sure what happened at Space City, but at Houston, I used the white controller for subsystems. Yeah. The green is the condition. So you'll see in here, there's a lot of on true, on false, on true, on false, on true, on false. We use mostly that. What on true means is that in order for this code to run, the button, the left stick has to have a signal. It has to be, the fact that the left stick has a signal, it has to be true, basically, is what I'm saying. X class. I'm getting to cyan. Speaking of, so green is the condition. There's on true. While true is while there's a signal, schedule the commands continuously. On true is just schedule it once. And I'll talk about command stacks later on today. So in cyan, we have specifies that the method in the X class. So basically what that means is that the expectation is that when you run, when you configure button bindings, you're connecting a button to a command. But a lot of times, you put methods directly inside of the subsystem's function, in the subsystem's file. For instance, in the shooter class, I put speaker scoring, which is just the function to rotate the speaker, have the shooter speak, not rotate the speaker, have the shooter shoot the note out. I put that function directly in the subsystem's class because it's simpler that way. It's easier. But the code doesn't know that that's a command until you say it's a run command. It's a command. That's what cyan is for. So X class is just whatever class you're referring to. So blue is what specific method to execute. As you can see here, there's a lot of methods in shooter. Which one do we actually do? In this case, speaker scoring is the method that was ran. And finally, in purple, we have to talk about the subsystem involved. So in this case, it's M_shooter. Now, the reason why you have to refer to by name is because sometimes you're going to have multiple of the same subsystem on a robot. The arrow thing does have significance. It's just it just has to be there. I'm not Java. Okay, some of the stuff Java is it's boilerplate. It has a lot of redundancy in it. So yeah, it's just a Java quirks. It's just part of the Java quirks and features. So just make sure that, again, you don't have to memorize it. Just note that every single one of these has the arrow in it. So hopefully the arrows don't scare you. So Kalayani asked, what is the difference between on true and while true? I am so glad you asked that question, Kalayani. I'm so excited to answer that one. I'm gonna assume Pranay doesn't have the same question and answer his first. Oh, he does. Okay. I think now would be a very good time to talk about first of all, let's talk about the fact that if you are in this VC, you should have your nickname changed to your real name in some capacity. So I don't know who Guy is unless that's your actual name, in which case I apologize in advance. Yeah, so please change your Discord nickname to your real name. Otherwise, I do not know who you are. And I might have to remove you, unfortunately. Okay, so yes, that was out. I was gonna get to that actually. So the difference between on true and while true. I'm gonna use this space right here to explain it. So the way commands work is kind of weird, right? So like, think of it as, I don't know, like a conveyor. No, think of it just as like you have a bunch, like you have like a stack of stuff, right? Or you have a queue. You have a queue. So in a queue, there's a thing at the front. Let's say that there's a lemonade stand at the front, and there's a bunch of people in the line. You join the line from the back. So the way it works is that every single time you run a line like this, you schedule a command, basically. So in this case, it's speaker scoring. So what onTrue would do is that it will schedule the command once. It'll add one person to the line. Okay, so like let's say that this is like the stack of commands that the code has to operate. It'll stack one. It'll do it once. And the reason why like just one press. So like if we didn't have an on false, on true would actually cause the shooter to run continuously if you just press it once, even if you let go, because the way it works is that if you set a motor to a certain power level, it will just keep on running that power level forever until it's told to run a different power level. So in this case of speaker scoring, apologies. In the case of speaker scoring, it sets the top motor and bottom motor to a certain power level, to a certain voltage, I believe. I believe it's voltage. It sets it to a certain amount of voltage, and it just stays it that way. It keeps on feeding that amount of power to the motor, so the motor will always spin at that speed. And what on false does, it does the same thing, except it schedules a command once the button is, when it detects that it's no longer there. So that's why when you hold it down, it'll always keep spinning, but when you let it go, what's going to happen is that, before the motor was spinning continuously, right? It was spinning at the same power level, right? When you let go, it's told to spin at a different power level, and in this case, that power level is 0. So that's on true. And the reason why I didn't use while true is because what while true does is it doesn't schedule one command. While true schedules commands all the time. It keeps on adding people to the line. So like we don't need to do that. It's redundant. And what that also ends up doing is it disturbs it clogs up the space in the console, first of all, because it's going to run the same line of code multiple times, even though it has to be only run once. So it's like, imagine like instead of having one plate or one thing on your plate, you get like 5 steaks every second on your plate. How are you going to eat all those steaks? You won't. So that's what while true does. It does all of this, and overall, I don't think it's used too often. Maybe in some cases that we will discover maybe next year, but this year we used on true and while true, because on true, and also the convenience of on true is that if you like, for example, if you're lazy, you just have to press it once and it'll keep spinning forever, and I guess it also apply with while true, but on true is just less janky. It's less disruptive, and it's overall more concise. While true is just pretty redundant. Though again, it does exist for a reason. We just didn't use it in this case. We used on true and on false. So I hope that answers both Kalyani's and Pranay's questions. If y'all have any further questions, please let me know. Let's take a look at another example. So that's what this runs. This line of code runs. Yeah, on true is basically it runs the command once the button is pressed. Like if the moment it detects a signal from the button, it runs the command only once. And then on false is just the moment it no longer detects a command, it runs it once. Yeah. So while it just continually runs the command while the button is being held, but once the button is no longer held, it'll just stop scheduling the command. But while the button is held, it'll keep on doing it over and over and over again, and that could be annoying in some cases. It could cause like jitter issues. Like I remember it caused like some jitter with other subsystems, so it does it is kind of disruptive. Let's take a look at another line. So, what about for the joysticks? The joysticks, the drivetrain, that's handled by these lines of code. So like, that's handled by this. And for joysticks, we didn't use them this year, but if I had to guess, it would just be like, because the joysticks are like a completely different use case. You don't like use the joystick. Like, I guess what you could do is you could put it under a new run command. You could put it like here, because this is what we use for the drivetrain. What ends up doing is that it just constantly runs the drivetrain, but it sets the speed of the motors to be dependent on the state of the joysticks itself. So you wouldn't use on or while at all. You would actually use a different run command, and then you would instead get the level, I guess, of each joystick. All right. I hope that answers your question. If after this like lesson you still don't understand, I could give you a deeper explanation into it. But unfortunately, I do appreciate all of y'all's questions, but we do have to move on to another example. So take a look at, well, I guess it's not line 138 anymore. It is line 141. Take a look at line 141. So this is an example of a command, a pure actual command getting run under configure button bindings, rather than just a function within a class. So it looks a little bit different here. So again, take a look at that, examine it. So in this example, red is still the controller involved, and then orange is still the button involved. So it still like connects a button to something, and there's still the condition there. So on true would just be like, when I find a signal, the moment I see the button is pressed, I run the command. And because we are working with an actual command here, we just have to put the commands. We just say, okay, we declare a new instance of the command called an Amtrap PID, and then it'll just run that with these parameters in dark blue. So in this case, the parameter of Amtrap PID, if you go to the command right here, in this case, the parameters are the subsystem. So again, there could be multiple subsystems, and then as well as the set point, the height to set it to. So those are the parameters. You feed those in as well, and it makes a new command with those parameters. Hi, Andy. Anyways, so that's another example of a line in configure button bindings. Are there any questions before we move on? This is the time for questions, because we're going to talk about commands later after this. Going once, going twice, going 3 times, and I assume that everyone is on board, perhaps? Again, if you want to DM... Oh, yes. No, it's all good, Kat. Do you have a question? All right, go ahead. Ask away. Yeah, if it was shooter, like, you wouldn't really have a height to raise it to. Yeah, that's a good question. That's a good question, actually. So, an example, you actually, like, pointed out a good example of that. So for those of y'all who are wondering, Kat asked, for a subsystem like a shooter, it would need parameters for, like, the angle, right? And that's actually the pivot's job. So if you look Under here, if you went to lines 138 to 139, that's another example of a command getting instantiated. So notice how the command is pivot PID. It involves the pivot, and the other parameter is the set height. So like the angle basically. Source pose is it's the variable for the position you. So Kalyani, I'm sure you know this. But basically, when we had the Amtrap elevator, we would intake directly from the source where you fed notes into the robot or onto the ground. So source pose is just the variable that like Amtrap constants.source pose. It's the height at which, if you raise the elevator to that height, it'll be at the perfect spot to intake a note from the substation. Okay, I hope that also answers your question as well. Yeah, that does use a PID to get the height to the right level. Yes, it does use a PID. Yeah, so it's the pivot's job in shorts. The pivot's job is to basically angle the shooter at the correct angle. Okay. All right. So this is what ends up getting run. And speaking of, let's talk about a command. So, for those of y'all who are here for session 1, actually both of the people who did this were actually in this voice chat. Can everyone please give a round of applause to Kat and Nicholas? Because 2 weeks ago, I asked y'all to look at amptrap.java, and analyze it line by line. Well, now we're going to take a look at amptrappid.java. We're going to do the same thing. And by the way, for wondering, Kat and Nick were the ones who did this line by line analysis, sent one to me, and I gave them a shout out. And that's their shout out again, because there wasn't anything to shout out about from last week. There will be from this week though. So if you look at amptrap.java or amptrappid.java, I'm just going to go over it line by line. So lines 1 through 20 are the file imports. So line 1, it's the command package. It specifies that, yes, this is indeed a command. Lines 3 and 4, these are related to Rev Robotics. For example, the Spark Max that we used on the Amtrap, the elevator specifically. And also, can Spark low-level.motor type is just the type of motor. So there's brushed motors and brushless motors. We use brushless motors, so we had to specify the fact that we were using brushless motors. Line 5 is very important. We want the constants for the amp trap, so that includes the elevator heights to raise it and lower it too. We want the subsystem itself. So this is Amtrap PID. That means that it has a set of commands that are relevant to the Amtrap subsystem. So we need to import those commands as well. So that's what line 7 does. Lines 9 through 12 are just more hardware stuff. We didn't actually use an absolute encoder for this one, so it's just kind of redundant. Lines 14 through 16 are more commands. For example, in line 14, wait command is just a command that's like, okay, I'm gonna wait 2 seconds and do nothing. So that's in like, if for example, like you want to like add a delay to an autonomous routine or something, that's what a wait command is for. Okay. Line 18 is the PID controller. More about that in 2 weeks' time. And then finally, line number 20 is the smart dashboard. In case you wanted to use it, we didn't end up using it this year for the PID command itself. We did do it for the Amtrap subsystem. So again, command, subsystem, very different stuff. Low key, when you write your code, how do you test it out when you don't have the robot on hand? You don't. Now the environment does tell you, like, hey, you're missing a semicolon here, or like, hey, you don't have a bracket on this end. But the truth is you don't know how your code works exactly until you you don't know how your code will operate until you like actually test it on the robot. So I guess it's blind coding is not a good habit without proper testing more often. But there isn't really a way to test your robot code unless you like run the thing itself, because there's a lot of factors. Yeah, it's a pray you hope. But there's many ways, there's a lot of good practices you can employ to make sure that, to increase the likelihood that your program works as expected. CS can get weird sometimes, y'all. Yes, yeah, okay. Moving on. Lines 22 to 34 are about initialization. So when you declare, like for example, in line 138, when you run that line, when you press down the Y button, this is what gets run first. Lines 22 to 34. So line 23 declares the name of the subsystem that we're going to refer to. So in this case, every single instance of the AmpTrap subsystem will be with this name right here. So again, if you recall my metaphor from the first session, I want an AmpTrap, and the AmpTrap is named AmpTrap subsystem. That's your nickname. Just how, like, for example, if I call Andy, like, I don't know, Young N, and he's like, no, my name's Andy, but I'm like, no, your name's Young N now. That's what this is. That's what's happening. We're giving a nickname basically, and that's how it's going to refer to this specific object. That was just an example, Andy. Hope you're not offended by that. Line number 24, the PID. That's what that is. It declares the PID controller. Lines 26 to 34 is the constructor. So this is where you initialize, first of all, the AmpTrap subsystem, because what if, for example, we had like 4 of them on our robot? We want to know which one is referring to us. Kat asks, what is a double set point? Not sure what that refers to. Could you please specify what a double... I don't know what a double set point is. Oh, double set, okay. Yes, okay, yeah. So this is just a parameter. Set point is like the name of the variable. That's the height. Set point is like, in a PID, the set point is where you want the thing to go. Like the height you want it to go at. So that's what set point is. And then double is just the type. So like if you recall like doubles, integers, strings, booleans, that type of stuff. A double in this case is a decimal number. And we generally use decimal numbers all the time in code. I don't think we ever use integers unless it's for like a SparkMax ID, where you can't use doubles or decimal numbers. So that's just a parameter. So just so how, like, for this right here, it's, again, you are a double and your name is set point. That's what double set point means. So a double, in this case, if you're familiar with that, it's a decimal number. Okay, and then add requirements. I will talk about this line. You don't have to worry about this too much. Line 33 is pretty important though. Add requirements, what it means is that it's just a way of saying, hey, if you want this command to work, like Mr. WPI lib, Mr. Visual Studio Code, it's basically you telling the compiler, hey, if you want this line of code to work, you gotta have an AmpTrap subsystem, otherwise nothing's gonna happen. So that's what add requirements is. It's literally you adding requirements that you have to, we have to require an AmpTrap subsystem in order for this command to work. And it's generally a good practice to have this in all of your commands, because if you don't have, for example, an AmpTrap subsystem, what are you gonna run? It might cause an error, it might cause the robot to go haywire. So line 33 is just there for moral support and insurance that your program will work correctly. Lines 39 to 40, this is run once when the command is started. Lines 42 and lines 47 are ran 50 times per second while the command is active. And once another command takes over and is run, lines 49 through 53 are ran when the command is stopped. And then lines 55 to 59 are just there for debugging purposes. Yeah, they run 50 times a second. So like, for example, if you want, for example, like a command, if you like in the PID, you want the power level to the motor to continually update to go faster or slower depending on how far it is from the set point. You'll do that in execute. So that's what line 44 is for. It just calculates the speed to go at. So it runs 50 times a second. Yes, I believe, yeah, it's set in the code. It's like, I'm like, if I get this wrong, I'm sorry, but like, I believe in the documentation it says something about how execute is once every 20 milliseconds, so that's 50 times per second. All right, so that's amptrappid.java. Just a quick overview. At override, that is basically it's a signal that this function is the one to look at. So this initialize function, this execute function, because if you notice, Amtrap PID actually is an inheritor. It actually inherits from command. So command is the base class. Amtrap PID is like a subclass. It inherits from command, and that carries with it some methods. And if you just don't have these overrides there, I believe it should still work. It's a little Java quirk, but that at override is just there to ensure that that function is run instead of the other ones. I think at override, again, correct me if I'm wrong, but just at override is just one of those, like, it's like when you're playing, like, I don't know, a video game, it's a passive mob there, and it does something. It might do something, it might not, just leave it. It's one of those things. Again, coding can be very quirky sometimes, especially Java. All right, so that's amtrappid.java. Are there any questions before I move on to the next slide? All right. Please do not be overwhelmed or intimidated by all of this. So your task, so before June 14th, first of all, learn Java. I recommend Headfirst Java as like a quick textbook introduction. And once you know how Java works, go ahead and give me a line-by-line explanation of another subsystem or command. And I'm actually going to add into this one a bonus. There's actually an additional command that I was able to upload here. Auto pivot PID. That's another option for a command if you want to analyze that. And then DM me a line-by-line explanation of what's going on. So you could either pick these two commands, or you could pick pivot.java or climb.java. Pick one of those. Just pick one of those four. You have a choice. 4 possibilities. So I expect a very diverse pool of explanations here. So in your explanation, additionally, list the lines in robotcontainer.java that relate to the subsystem or command you pick. So instead of lines 127 to 180, it is now, I believe, lines 131 to line 182. So 131, 182. So just list me the lines in configure button bindings that relate to that specific command. So for example, for Amtrap pivot or for Amtrap PID, those two lines would be 141 and 142. You just give me that as an example. So do that for the specific Java file that you decide to analyze. And then finally, as an optional bonus, if you want to, you could watch the Zero to Autonomous series of videos. These are some very helpful. Okay, first of all, it's a video lesson, not a lecture. It has diagrams, it has examples of a robot, and it's another perspective on how to approach it. And then I would start with video number 5. So there's 6 videos in total. Videos 1 through 4 will not help you a lot because those use a time-based robot. So timer-based robots are very simple. They're very simple programs. but we are using command-based for programming and not time-based. So videos 1 through 4, they might be helpful. I believe one of them is about PID, but video 5 is where it's at. Command-based programming. That gives you all of the details about like how the program is structured, and anything that I missed or I might not have explained clearly, you might find useful in those videos. But it's optional. I'm not gonna like go through your search history and see if you watched it or not. I'm not gonna like enforce this. If you want to, it's supplemental. It's a good resource. I watched it when I was learning how to program for FRC. You should too. You don't have to though. So just learn Java. Make sure that you learn what Java looks like, the basic ropes. Learn the ropes of Java, and then pick from one of these 4. And then DM me a line-by-line explanation of what's going on, similar to like what I did here. And then, yes, enjoy the rest of your summer. School's out, unless like if you're NHISD in basically every school in the Houston area. So enjoy your summer. I hope this does not take like out more than like half your day tomorrow. If it does, then I'm sorry. Are there any final questions about anything we've done today before I let you guys off, go to back to your lives? Nope, thank you. Very good question there. Anyways, I was just joking. So thank you guys for coming. I will see you guys next Friday, June 14th. Have a great rest of your day, whatever's left of it. Have a great rest of your week. Have a great rest of your summer. Stay safe, and goodbye.